All right, we're going to pick up on problem 15 where we left off. We're going to keep working these time value money problems. Number 15 says, suppose you fall on hard times and need to get a payday loan. The terms of the loan are as follows. You write a check to Payday Inc. for $120 that is post-dated $10 from now, and they'll give you $100 today. We need to figure out what the APR is and what the effective yield is. All right, let me explain something here. APR stands for annual percentage rate. And an APR assumes that interest is only compounding once per year. All right. The effective yield, or sometimes we call the effective yield the effective annual rate, is a rate that tells you that accounts for compounding. And I'll explain as we calculate this problem here and solve for the interest rate. Okay. So let's see. Let me explain to you some math here real quick. So to calculate the effective annual rate, what we're going to do is we're going to find the APR, okay? And then we're going to take 1 plus the APR divided by C, where C is the number of compounds per year, all right? So in this particular problem, we're looking at a 10-day loan. So C is going to basically, I'll ask how many 10-day periods are there in a 365-day year? And you can do that in your head, or you can divide 365 by 10. And that's going to give you 36.5. So there are 36.5 compounding periods in the year in this particular problem. So we're going to take 1 plus the APR divided by C, raised to the power of C, and subtract off 1 to get our effective annual rate. I'll also teach you how to solve this on your financial calculator if this doesn't make sense, okay? So let's do this. Let's do this in Excel. This is problem 15 here. So what we'll do is we're going to take, we have to first solve for APR. And to solve for the APR, again, what we're going to do is we're going to solve for the interest rate, the 10-day interest rate. To get the 10-day interest rate, I'm going to take the $120 that we owe minus the amount of the loan, $100, and divide that by the amount of the loan. So this tells me that the 10-day interest rate is going to be 20%, okay? But the APR is something more than that, all right? So the APR is going to, what we're going to do is we're going to multiply this. We're going to multiply this by 36.5, or the number of compounds per year. And when we do that, we get 7.3. That's not 7.3%. I'll remind you that 120 minus 100 divided by 100 is going to be 0.20. So this is in decimals. So 7.3% is actually in decimals. The APR is going to be in percentage terms. I got to multiply that by 100. It's 730%. Okay. So you learned in the previous video that don't make minimum monthly payments on your credit card. Here you're learning don't get payday loans if you don't need them. All right. So now that we have the APR, we're going to calculate the EAR, or the effective yield. And we're going to follow that formula. All right. And whenever I use the formula, I'm going to use decimals and not percent. So I'm going to use cell B15 as my APR. So I'm going to say this equals 1 plus the APR divided by 36.5, the number of compounds per year, raised to the power of 36.5. Okay. I got to do one more thing here. Sorry, I missed a parenthesis here. Once I do this, I'm going to subtract off 1. Need another parenthesis up here. And that gives me 775.45. Again, is that in decimals or percent? Again, I've got to take this thing and multiply it by 100 to get it in percentage terms. And this is insane. So this particular loan has an EAR or effective yield of 77,545% once you account for compounding. What this suggests is that on January 1st, if someone comes in and gets a payday loan, a 20% loan for a 10-day period, and then 10 days later, they come back into the place and they get a $120 loan to pay off their first loan. And then 10 days after that, they come in again and get another loan that's larger than $120 to pay off the second loan, and so on throughout the entire year. What they will be doing is paying 77,545% once you account for that compounding. All right. So you're either saying to yourself, I'm never going to get a payday loan, or you're saying to yourself, I should start a payday lending place, right? And listen, I'm agnostic. I'm agnostic to whether or not payday lending is predatory. In fact, there's some economic research that suggests that states that allow for payday loans, and by the way, there are some states that restrict payday lending. States that allow for payday loans actually have less bankruptcies, personal bankruptcies. And so it does seem that people are using these payday loans in a way that helps them avoid bankruptcy. And so I'm going to be agnostic about whether or not states should allow these types of things to occur. But you, as a student, should see that that the interest rate on these things are insane. Okay. Let's answer number 16. This is going to be an interesting question too. Okay. Number 16 says, what is the present value of an asset that pays $5,000 for the first 3 years, $7,500 for the next 3 years, and $10,000 for the final 3 years at the discount rate of 7%? Let me show you how to solve this problem. It's actually pretty easy. We have 0, 2, 3. Sorry about this. Should have been more prepared. And it looks like the cash flows from this asset are as follows. In year 1, we have $5,000. Year 2, we have $5,000, and so on. Year 4, careful. And years 7 through 9, it's up to $10,000. Okay, so this is what the cash flow stream looks like over the next 9 years. And what we need to do is we need to find the present value of an asset that pays out these cash flows. All right. So this actually becomes pretty easy. All you need to do is solve for the present value. You need to treat each of these, even though the payments are the same for 3-year segments, they're not same throughout the entire 9 years. So you can't use the payment function. You can't use the payment function for these 9 years. So what you're going to have to do is treat each of these cash flows as a future value. I'm going to solve for present value. My rate is my discount rate. Okay, number of periods. How many years am I discounting this first $5,000 back if I treat each of these cash flows as independent future values? Well, I'm going to discount this one back 1 year. So I'm just going to highlight this cell. My payment is 0. Again, I'm treating these things as future values, and my future value is going to be this particular cash flow. I'm compounding at the end of the period. I'll let that sit for a second. All right. So really what I'm doing is I'm going to calculate the present value of this first year's cash flow, but I'm treating this first year's cash flow as a future value, not a payment. So payment is equal to 0. Future value is equal to 5,000. And I get a present value of $4,672.90. Now watch how easy this is. I'm just going to highlight that cell and drag, and it's going to produce the present values of each of these individual cash flows, treating each of these cash flows as future values. To get the present value of an asset that pays these cash flows, I'm just going to sum this up. The sum of the present value of these future cash flows is $46,675.18. Okay, so that problem initially it looked a little bit tricky, but it's not. It's actually pretty straightforward. Just treat in this again. The purpose of this problem was to show you that while the payment function is easy to use in the time value money calculations, if your payments aren't constant throughout time, then you can't use that payment function. All right. So here we just treated each of these individual cash flows as future values to solve the problem. All right, let's keep going here. Let's solve number 17. And then in the final video, we'll solve the last 3 problems here. So in 17, it says an annuity due makes a 5 payments of $3,500 has a discount rate of 8.5%. What's the present value of this annuity due? Now, since the payments are constant, we can use the payment function. However, let me introduce a new concept. In class, we talked about an annuity being a stream of fixed payments. That is, the payments are the same for a fixed period of time. All right. What we didn't talk about was that there is actually a financial instrument called an annuity. So if let's suppose that you save up $5 million for retirement, you turn 65, you've had a salary all of your life, and there are companies, insurance companies generally, that will have you buy an annuity. All right. So in other words, you could give the $5 million to the insurance company, and the insurance company in return might give you, say, $350,000 a year for as long as you and then your spouse lives. Okay. So this contract that you pay to an insurance company to receive fixed income during your retirement years is also called an annuity. Now, the difference between a traditional annuity, like the one I just described, and an annuity due is that the annuity due makes the payments at the beginning of the period instead of the end of the period. So this is the one problem in our course where interest is not going to compound at the end of the period, but instead it's going to compound at the beginning of the period. If this were a traditional annuity, we would receive the $3,500 at the end of each year. Does that make sense? But an annuity due suggests that we're going to receive these cash flows instead of at the end of each year. We're going to receive them at the beginning of each year, starting with today. Okay. So to calculate an annuity due, this actually is really easy. Again, what am I solving for? Problem 17 suggests I'm solving for the present value. How frequently does interest compound? I'm receiving the payments in each year, so the interest is going to compound annually. And these payments are going to be inflows, right? So they're going to be positive numbers. Take the present value. My interest rate is this discount rate, 8.5%. Number of periods is 5 periods. Payment is a positive $3,500. And note, I'm not receiving any lump sum amount after these 5 payments have been made, so the future value is going to be 0. And the only difference between calculating a traditional annuity and an annuity due is I've got to change this. So instead of the end of period, which is the default in Excel, what I got to do is push 1 to make sure that the payments are being received at the beginning of the period and interest is compounding at the beginning of the period. I'm going to close my parenthesis. And this particular annuity, according to this discount rate, this particular annuity due, according to this discount rate, is going to be $14,964.59. Okay. By the way, it might be useful to calculate what the traditional annuity is. My rate again is 8.5%. Number of periods is 5. Payment is $3,500. Future value is 0. And a traditional annuity would the interest would compound. The payments would be received at the end of the period. So I'll put 0 in there. And notice that the traditional annuity is going to cost less than the annuity due. And I would ask why. And hopefully it makes sense that this is going to cost more. The annuity due is going to cost more because you're receiving these payments sooner rather than later. Okay. So the annuity due, all you have to change is that the interest is going to compound at the beginning of the period instead of the end.